Hey everybody, thanks for coming to my talk. Um, it's titled Exploring the Lightning Network Using Memgraph. So my name is Vincent. I'm the Senior Data Scientist at Amboss Technologies. There's my email if you want to reach out, and if you like shitposts, there's my Twitter handle. So just to give a quick intro, or an overview of what we'll be talking about, I'm going to give a quick intro to the Lightning Network. I'm sure a lot of you are already familiar with it, but just to make sure that everyone's on the same page, just going through a quick intro of the Lightning Network, followed by discussion about Memgraph and LN Stream, which is a project I created to load data into Memgraph from a snapshot of the Lightning Network. Then we'll get into some interesting Memgraph queries and how you can stylize visualizations so that they're more informative. And if we have enough time, I'll also be going over some other tools that you can use. So let's get into it. So the Lightning Network. The Lightning Network is a layer 2 payment protocol built on the Bitcoin blockchain. For it to be a layer 2, that means that payments occur off-chain and there's a trustless settlement to the base layer. Here's a picture of the Lightning Network from February 12, 2019. I've cited the paper below, but this was one of my first inspirations when I was researching the Lightning Network in university. I just thought this visual was pretty interesting because you can see at a glance what are the influential nodes in the network. The one in the center is async, and you can see how these edges sort of cluster towards it, and it's the most influential node in the network. And yeah, just the layout with influential nodes and then smaller nodes in the periphery. Just an interesting visualization. And it was my original profile picture on Twitter until I was able to make one myself. So just some lore. Let's go over the life cycle of a channel. So a channel is between two parties. In this case, it's Alice and Bob, and one or both have to own some amount of Bitcoin. So in this case, Alice owns and controls 4 Bitcoin. She'll deposit these funds into a payment channel controlled by both parties. This is just a 2 of 2 multi-sig address. It requires 2 signatures from 2 parties to update, to change. So when these funds are deposited, that's called the funding transaction, and each party maintains a copy of the latest balance and can close the channel at any time. So this document with the green check mark, that's their commitment transaction for closing the channel. And the balance of the channel is updated when both parties sign a new closing transaction and then poison the old one. So this is one of the reasons why Lightning is a scalability solution to Bitcoin. They defer broadcasting this commitment transaction, so sending that Bitcoin from Alice to Bob happened instantly and was free. Funds are dispersed to either party when the commitment transaction is broadcast to the blockchain. But until then, an unlimited number of payments can take place between the 2 parties. So after you close it, the funds are dispersed according to the commitment transaction. Payments can occur between nodes even if they do not have a direct channel. So in this case, Alice has a channel to Bob, and Bob has a channel to Charlie. And you can see that Alice controls 3 Bitcoin, Bob controls 3 Bitcoin, and that Alice could forward a payment through Bob to Charlie. And how does that work? So hash time lock contracts allow for the atomic relay of payments through intermediate nodes. Funds are locked into decrementing HTLCs. In this case, the first one is between Alice and Bob. You can see there's a clock and a lock. That's just to signify that this will expire after some amount of time if Bob doesn't produce the preimage that this Bitcoin is locked behind. The preimage to the hash that this Bitcoin is locked behind. Bob then locks funds into an HTLC to Charlie. Charlie knows the preimage, and when he reveals it, that settles it on their side, and then gives Bob the ability to settle it on his side. So they're unlocked in reverse order, and there you go. So this is another reason why Lightning is a scalability solution to Bitcoin, because you don't need a direct channel to every node in the network in order to send them funds. But the drawback is that relaying payments requires liquidity. So in this situation, Alice can send a payment to Charlie through Bob, but the reverse is not true. So Charlie cannot send any payments through Bob to Alice. He doesn't have any liquidity on his side. And then the real kicker is liquidity is not public knowledge. So this is Alice's perspective of the network. She knows that she owns and controls 3 Bitcoin in a channel with Bob, but she doesn't know who owns what in the channel between Bob and Charlie. So you can't win everything. So getting into forwarding policies, obviously Bob's not going to provide this service to Alice for free unless they're good friends, but there is some risk involved. You are locking money into something. There's a chance that things can go wrong. There's a forced closure, and you end up paying some expensive mining fees. So there's forwarding policies. Bob can describe to Alice how he'll forward payments on her behalf to Charlie. And the different options you have are the fee rate, millimsat. So the denominations in Lightning are cursed. So just think of millimsat as parts per million. This would be a scaling fee for relaying payments. It'll increase as the size of the payment increases. Then there's base fee MSAT. So this is a base fee. Hello? This is the base fee that you would charge for relaying any payment. Minimum HTLC, so the minimum forwarding amount that you're willing to forward on somebody's behalf. Anything lower than that, you will not. Maximum HTLC MSAT, so the maximum forwarding amount. Anything greater than that, you will not forward. And disabled, so whether this channel is disabled for routing, and lock time delta. So for how long are these funds locked up? Just a quick example, Bob charges 1,000 parts per million and 1 sat base fee to relay payments towards Charlie. So for a 1 million sat payment from Alice to Charlie, Bob would receive 1,001 sats from Alice and then send 1 million sats to Charlie. And then node attributes. So nodes have several attributes. Their public key, which is pretty much their identity on the network. An alias, which is the human readable name for the node. A node color, which is useless. Features that the node supports. So for example, whether or not they allow for larger channels called wombo channels. And then the addresses, so how to reach them, whether it's over ClearNet, Tor, or not available at all, in the case for Binance. And then Memgraph. Oh, real quick. Are there any questions up to this point? What's up? Yeah, it's there. I mean, you can specify your color. I don't have a great visualization for this, but apparently all voltage nodes use the same color. So yeah, it's just, I don't know, it's a pretty useless feature, but yeah, it's there. Any other questions? All right, so Memgraph. Memgraph is an open source in-memory graph database. There's 2 parts to it. So Memgraph database, the actual database, and then Memgraph Lab, which is like a user interface. And what a graph database is useful for is pathfinding, recommendation systems, and also visualization. And then LN Stream. So LN Stream is just a control panel for loading graph snapshots into Memgraph. It can also stream graph updates from LND into Memgraph. So there's a simple front end plus a Go back end, and it comes with Memgraph included in the Docker. So let's do that. Here's a QR code for this link right here. Is anybody interested in downloading the project? Okay, so I'll leave it up for a little bit. And you can ignore what it says down here. There's no setup required. Give you guys a little bit more time. I see some scanners. Okay, is that everybody? Cool. So after this, we're pretty much off the presentation. Okay, so don't use this link when cloning it, just use this. You don't need the port number. We'll copy that. Git clone. Oh, maybe. Perfect, okay, great. Yeah, thank you. Waiting for it to download. It also has a snapshot of the network included, so that's why it takes a little bit. We'll change directory into it and just see what's there. So there's a Docker file for describing the project itself, README with some instructions that are no longer relevant, a collection of queries that you can make into Memgraph, the snapshot itself, the Docker Compose, which orchestrates starting Memgraph in this project, and so we'll go there. Docker Compose up. And if you're running this on your computer, it'll take a little while because you have to download all the images, but I've already got them, so it starts up quickly. And you can see that it's listening and serving on 8080. And then we have Memgraph Lab running on port 300 or 3000. So that would be this, which is really just 2 buttons, and this one doesn't do anything right now. And then Memgraph Lab. So I won't be using Memgraph Lab in the browser. I actually downloaded it as the application, so we get a little bit more viewing area. But this is basically it. If it sees that Memgraph is running, it'll automatically connect to it for you. And let's see. So if we click load local snapshot, it'll drop the database. Should drop the database and then start loading in data from the snapshot. And there's about 98,000. Yes. Yeah, so 96,000 relationships. Yeah. And then from here, so I've already got the collection added, but here, give me just one moment. Yeah, so here, create a collection. Name doesn't matter. Let's say Bitblockboom. And then to import the collection of queries. This would be in the folder for LN stream, and it would be that, but it's not letting me click it. Hold on. There it is. Weird. All right, and then so here's all of our 16 queries. And yeah, that's all in the repo. Good question. And then I'm going to use that. Yeah. And the only reason I'm doing this is so that we don't have the toolbar up there and we get a lot more room. And if you guys can't read that, I'll just describe it to you. But this first query is about 0-degree nodes. How many nodes exist in a Lightning network without any channels at all? You see that there's 15,629 nodes. Here, let me just... No, it's if they have no open channels at all. They might be private, so they're unannounced, but apparently to us, you don't see any channels. So This first query will match all of them and return the count. The next one just deletes them because we don't really need them. But in this first query, there's 3,531 nodes on the network with absolutely no channels or no public channels. And these next are just to like set node capacity. So summing up the capacity of each channel you're incident with and setting that as a node attribute. So here's just the list of the largest nodes in the Lightning Network. First with Async, OK Exchange, Bitfinex, Binance, Kraken, LN Big's got a couple, Wallet of Satoshi, Nice Hash, and how much capacity they have. So this is what, 464 Bitcoin. So setting that, getting the nodes betweenness centrality. So betweenness centrality is the ratio of shortest paths that you lie on versus all shortest paths in the network. Higher is better. In this example, Async lies on 14% of all shortest paths in the network. They have the most betweenness, followed by 1ML node alpha, CoinGate, Wallet of Satoshi. And you'll see a lot of these names pop up again. Liquid's an interesting one because they have less capacity than most nodes, but they have an outstanding betweenness centrality. And this, it's going to get exciting. This is just setup. So these are fee ratios. So here. That's too much. So when we talk about fee ratios, that's how much you charge on outgoing channels versus what is being charged on incoming channels to you. So for example, River Financial has a huge incoming average fee, but a very small outgoing average fee. So for a ratio of 0. So in other words, this node charges 0 times what it costs to receive to send. And this can be useful for identifying sources and sinks in the network. So if you have I might get this reversed, but if you have a high fee ratio, that means that you charge more than what it costs to receive to send. So you are very protective of your outbound liquidity. So using that, it will help us identify sources and sinks in the network. So let's just see what popped up. Well, the first one sets it. This one might not be sorted. Yeah, this one's not sorted, so we can move past it. Fixing denominations, like I said, they're cursed. So this just updates a node attribute in the fee policy to be the same denomination as the other two. Then a fake edge betweenness. So edges can also have a betweenness centrality, and that it's the same concept but applied to a specific edge, not a node. So for example, channels between CoinGate and Async have the highest betweenness, and that makes sense because they're both high betweenness nodes. Disabled network. So this one is interesting. This will be the first visualization. When you disable a channel, it's for it's for two possible reasons. So the first one is that the node that this channel is with does not manage the liquidity, and so if you're a routing node, you don't really want to attempt to route along that channel because you know it's going to fail. So you're saving some time there just by disabling the channel. The other possible reason is that that node is, you're protecting your liquidity towards that node. So you don't want to sell that liquidity. You've disabled that channel for routing. So let's see.
Betweenness means the amount of hops it has to go to reach some other.
No, it has to deal with shortest paths. So if you have many connections in the network, chances are you lie on a larger number of shortest paths for a given pair of nodes, right? So they go through your node to reach the destination. So having a high betweenness means that you're more central to the network when it comes to routing. Yeah, good question though, thank you. Okay, so this is the disabled network. So these are all the channels in the Lightning Network that are disabled, and it's probably the slowest visualization. Okay. Come on. There we go. And yeah, so as you can see, there's quite a few, and then some nodes have more disabled channels than others. So, for example, this is game B2, which is related to Sphinx chat. Let's see. 1ML node alpha. And so, yeah, I mean, it's interesting to think that maybe half of these are due to protecting that liquidity, the other half is due to the nodes just not managing their liquidity at all. The next one is where it's disabled in both directions. So it's just interesting to think, so this channel is definitely not being used for routing if it's disabled in both directions. And it might represent like do what? Well, it's more like they're protecting the liquidity for each other, so it's like a stronger business relationship. I mean, you can make assumptions about it, but that's what I glean out of it. So, I mean, it's interesting to see that all these nodes would have it disabled in both directions, and it might even be that these nodes, like especially for 1ML alpha, that these nodes that it's connected to that are disabled in both directions might be zombies. So just something to consider. So up until this morning, I was using Gossip, and it was streaming from LND into Memgraph, but because I'm away and networking is not the same, I had to disable that. But yeah, so there would be another button here that says load fresh snapshot, and that would be calling describe graph, RPC endpoint, and then piping all of that data into Memgraph. And then after that, turning on subscribe graph updates. So yeah, but right now it's just a snapshot from this morning. So yeah, so this is the disabled network. And then you can see, so like outgoing channels, who has the most outgoing channels disabled, and that would be 1ML node alpha, followed by CoinGate, Game B1 and 2, and then Sphinx routing, and so on. And then the other question, who has the most incoming channels disabled? So also 1ML node alpha. After that, Lucky Dog, bCipher, and so on. What's the last one? Oh, the largest amount of capacity that's disabled. All right. So this next one is just getting the nodes with the most betweenness. So we've already seen this, async, 1ML node alpha, CoinGate, so on. But let's see them in a graph. Okay. No. Hold on. Okay, all right. I thought I lost all of my styles. So there's a couple different ones. So size is just sizes of nodes based on either capacity or betweenness. Size and edges is the same, but also applies it to edges. And then this other one is for pathfinding. So just checking this out, you really can't see anything. Hold on. That doesn't help. Okay, well, sorry, hold on. A little bit of technical difficulties. They shouldn't move after I touch them. Okay. So yeah, I mean, from this visualization, you can see at a glance, there's a handful of nodes that have outstanding capacity out of the top 100. There's maybe just a handful that really just dominate in terms of capacity. And the rest are smaller nodes. Let's see. So that's based on capacity. Let's see betweenness. So here's the interesting thing here is that even though these nodes have a huge amount of capacity, most of them have a small betweenness. And then you'll see nodes like this. Let's see, one node alpha has a low total capacity but a high betweenness. So that means they're provisioning their liquidity in a way that makes them more central to the network. They're doing more with less. And so yeah, that would be the subgraph of the top 100 nodes by betweenness centrality. Let's see what else. The free network. So this would be the network of nodes in the network whose fee policies are 0 fee rate and 0 base fee. Let's see. So this first one will be the graph where it's free in at least one direction. So you can see Async, OK Exchange, Binance, Bitfinex, these larger nodes, Kraken, all having these free channels with other nodes. But what gets interesting is when we look at where it's free in both directions, because this can highlight some business relationships that you wouldn't expect. So this cluster right here, I think, is the LN big cluster. Let's see. Yep. So LN big, all operated by the same person. So of course they have free channels to themselves. Another interesting one, so I think this is River Financial, and then the only other node that they have a free channel with in both directions. Doesn't have a human readable alias, but, and bear with me, if we look this up online, apparently it's Chivo. So just an interesting dynamic. Yep.
It's just that it's closed between the different nodes, right? It doesn't transmit to the outside. No?
Well, it's that it's the only channel they have, like River has, that's free, that isn't with itself. So just an interesting factoid.
Free as in there's no fees associated with inbound and outbound channels.
Do what?
Free as in there's no fees.
Right. So yeah, let's see what else. So this one is, I think, Adam, Master of Pearls. no, that's Binance. This is, where is it?
It's really great that you can just click on a node and see what the information is.
Yeah, right? Sorry, it's really small for y'all. But yeah, I mean, it's just interesting to think that, you know, all of these represent relationships between businesses, nodes on the network, and that it's free to route between them. Let's see. These next ones are who has the most free channels, incoming free channels, so that's Adam, Master of Pearls. Some other nodes, followed by Binance, Sunny Sarah, which is a router, and so on. And then the most outgoing free channels. So Boltz has the most outgoing free channels, followed by Gspot, Async, Wallet of Satoshi, and OKX. Okay, paths between nodes with cost cutoff. So we'll run this just to see what happens. But this whole query is for finding between two nodes all of the paths that exist below a certain fee. So here, I really wish I could zoom. This is a payment of 100,000 sats with a max fee of 1,000 sats between these two nodes here. All of these conditions here are conditions specific to LND, so you can't route over a disabled channel, you can't route more money than exists in capacity of the channel, and so on. But yeah, so this would be the source, this would be the destination, and then here are all the paths that exist between them below that fee rate in 4 hops. Size plus colors, okay.
I'm just trying to think of an application of using information like this. Would it be if I wanted to open up a new channel to, I guess, reduce my betweenness within the network or make my node more efficient? Is this a tool like this analysis would help in that?
Yeah, so this one I think is just to show like the connectedness between two pairs of nodes. So, you know, if they're two businesses and they want to have a strong relationship, but they don't want to open channels directly to each other, this might be a way to visualize how well they are connected to each other, that sort of thing. And then just, you know, changing the visualization based on different aspects of the node. So like this is based on fee ratio. If the only paths that existed between the two pairs of nodes were nodes with high fee ratio, you would know that they're not well connected. It's pretty expensive for them to route to each other, route payments to each other, that kind of thing. Yeah, so I mean, just to describe the relationships in the network. But if you figure that out, you should let me know. Let's see. Oh, does anybody have a node they want to try? Do what? Pleb devs. All right. And who do you want to be the destination? Okay. And ZBD. Is it Zebedee? Okay. Ooh, 1 channel? Are you sure? No, because this doesn't show any channels. Different destination. Okay, we'll do C1 as the destination. And then let me just add a limit. So let's see. Um, Not necessarily. It's more just showing how strongly connected two nodes are. Yeah. Yep. So between the source and destination pair are all of the paths that exist below 100 sats fee. So you could send 100,000 sats through any one of these paths and pay about, what is that, 1%, 0.1%? Yeah, so interesting. I mean, so that's another reason why this is a scalability solution for Bitcoin. They don't need to have a direct channel. There's tons of paths in between them. One of them's got to work, right? Any questions about that one? Any other nodes you want to try? Yes.
I have a really big one-time Lightning payment on me. I know I'm gonna have to route it somewhere, and I'm like, okay, let me go dive into the data and maybe find a path that my LNG node wouldn't find.
Yeah. Yeah, so if you had some way to evaluate the paths without trying them, then all those that you get returned, you can just pick the best one and use that, right? So yeah, I mean, that's a goal of Amboss eventually in the future, and why I'm using Memgraph in the first place. Good question. All right, this next one is starting from a node, showing all of the other nodes that it could pay below a certain fee and below a certain hop count. So and with this style, okay, maybe not. Hold on, let me see what's going on with that. Just a moment. Oh, never mind. So, shoot. Yeah, okay. So this is the center node. These are all the nodes that it can pay for 0.1% fee. And I have a better visualization that color codes it. Should color code it. Right, okay. So with this node as the center, and then the size of the nodes is based off of how many hops away it is. So you can see that it can reach 5 other nodes in 1 hop, a much larger number of nodes in 2 hops, and then all of these smaller periphery nodes in 3 hops. And the reason why the size gets smaller by half, because you would expect the failure rate to double as the number of hops increases. Does anybody want to try out their node as the center? And do pleb devs again? All right, so pretty similar. With this node as the center, the orange one, there's 5 nodes about 1 hop away, many more 2, many more 3 hops away. But yeah, just, when looking at this, what you would want to see is something similar to this, hopefully more larger nodes than smaller nodes. But what you wouldn't want to see is almost no nodes. So that would mean you're not connected to the network in a way that you can send cheap payments. Let's see. For this one, yeah, 3 hops. And then I also have 10,000 path limit because it's not just finding one path from that node to some destination. It's like all cheapest paths between all of the nodes here in that source. But let's see. If I change it to just the shortest, just the first shortest, should be a little bit quicker too. Yeah. So let's do it anyway. Oh, so this would indicate that there's 6,560 nodes that you could pay 100,000 sats for a 0.1% fee. And then you can, because we're using a tree instead, you can see the clusters a lot more, which nodes are responsible for forwarding those payments. Yep. And then sinks and sources, which I'd mentioned earlier, is related to fee ratios. So these queries are going to get the largest sinks and sources in the network. And I know you can't read it, but that would be async, Binance, Kraken, LN Big, NiceHash, FixedFloat, and Loop as sinks, which makes sense. Loop is a massive sink in the network. And then for sources, Wallet of Satoshi, Cyberdyne, LN Big, Yalls.org, Torque, the Bitcoin Company, and Azteco. Just something to consider. You would want, if you're a routing node, you would want to place yourself in between sinks and sources. Next up is Wumbo nodes. So this first query is Wumbo only nodes. So that would be nodes that only allow channels larger than 16 million sats and change. That's Binance, Loop, Snow, Kappa, and this node as the top 5 largest Wumbo only nodes. Next up is mini nodes, so nodes that only have channels smaller than 16 million sats. And the number 1 is CoinGate, which is interesting because they're an exchange. You would think they'd allow you to open up larger channels, but apparently not.
Just going back, a sync, is that...
Do what?
A sync is a node that has free capacity to go in, but high capacity and high fees to go out.
It's more so that you expect them to be a destination for payments more often than a source for payments. Yeah. Good question. Yeah, so those are the Wumbo and mini nodes. And then the last one, which is Tor and ClearNet. So let's see. This first one would be the, oh, what happened? Okay. Well, shoot. This query would have returned data about nodes that only have Tor connections, nodes that only have ClearNet connections, and then sorting them based on capacity. Let's see. Can't remember the results, so this is going to remain a mystery. I think Azteco is the largest Tor-only node. But the reason why this would be relevant is these are the nodes that are relaying your payments. So if they're using ClearNet, there's going to be a lower latency versus if they're using Tor. So if latency for making payments is important to you, you would want to stick to ClearNet only nodes. So yeah, I mean that's pretty much it. Any questions?
Do you have some other good examples of where this has been helpful to you in managing nodes, running payments?
Mostly for pathfinding. That's been the biggest reason we're using Memgraph. Yeah, pretty much. I mean, eventually I'd mentioned recommendation systems, so graph databases are really great for that too. It could be, depending on the query, it could be, oh, I want to open up channels based on these channels that I've already opened. So make me more connected with the people I'm already connected with. Stuff like that. Or to look for gaps in the network, or like identifying nodes that have high betweenness but low capacity. That shows that they're being very intentional where they provision their liquidity. Yeah. Thank you.
Grandpa, why do you have so much Bitcoin?
Well, it all started in the year 2023 when I attended a conference called Bitblockboom.
What's Bitblockboom, Grandpa?
It was a conference where people talked about Bitcoin. This was way back when we used something called the US dollar for money.
What? Bitcoin wasn't always the world's money?
If it weren't for great speakers at Bitblockboom like Jimmy Song, Adam Curry, and Preston Pish, we'd all be living in pods and eating bugs. Instead, I was able to avoid fiat enslavement and secure generational wealth.
F***ing legend.
Be the legend your grandchildren deserve. Experience the best Bitcoin conference out there and join the Bitcoin revolution. Bitblockboom, the only conference for true Bitcoin maximalists. Book your tickets today at bitblockboom.com and use the code BBB1 for a special discount.